Hello, my name is Elizabeth Bennett, and this is my lab report for Lab 5 in Physics 2211. In this lab, I measured the change in position of a crumpled piece of paper and a flat piece of paper at the same mass. One way I did this was dropping the physical sheet of paper and tracking its motion with the tracker software. The other way was by modeling the motion using a glow script code. The fundamental physical principle used in this lab is Newton's second law, which states that force equals mass times acceleration. The velocity and position update formulas were also used, as well as the formula for the force of drag as seen on this slide. The overall results of the lab are that the flat paper experiences much higher drag than the crumpled piece of paper. Here's what the experimental video looks like in Tracker. The system consists of the paper, while the surroundings include everything else, including the earth and the air. The paper is initially at rest and starts at a position at the origin. The glow script code modeling only the force of gravity on the paper starts with the mass of the paper being defined as 5 grams or 0.005 kilograms. The initial position is set as previously stated, and the direction that the paper is falling is also set. The delta t is 1/30th of a second, meaning the position of the paper will be marked every 30th of a second. The gravitation constant on Earth is defined as negative 9.8 meters per second squared. In this code, the drag constant is 0 because we are only looking at the effects of gravity. The force of gravity acting on the paper is the mass of the paper times the gravitational constant. The updated velocity of the paper is equal to the original velocity plus the force of gravity times delta t. The position is updated using the position update formula by adding the velocity times delta t to the original position. Then the time increases by delta t. The code including drag force is the same, except b is now equal to 1.35, which is found using trial and error. Also, the net force is equal to the force of gravity plus the force of drag. The model on the top left shows the tracked motion of the crumpled paper from the video, while the modeled motion with no drag is shown on the top right. This is the same for the bottom graphs, except they model the paper's motion with drag. Overall, the results indicate that the paper without drag falls much faster, around 0.6 seconds, while the model including drag falls for 1.6 seconds. The length of the fall times are about equivalent for the tracker versus the glow script models, but the shape of the curves differ, with the no drag tracker code having a slight curve, but the no drag glow script code showing linear motion. Also, the drag tracker code is roughly linear, while the drag glow script code is slightly curved. These errors could be due to the paper falling in a z direction that we can't capture on a 2D camera, and errors in estimating the b value because that was just trial and error. Thank you.